Hi everyone. Today we're going to look at a divergent plate boundary, and specifically we're going to look at a divergent plate boundary that has two pieces of oceanic crust on either side of it. If you should need to get a hold of me, my email address is the best way to do that. It is on the screen. So one of the things I want to keep reminding you is to understand what's happening at any plate boundaries. You have to ask yourself these two questions. How are the plates moving? Are they dividing? Are they colliding? Are they sliding past each other? Are they divergent, convergent, or transform? And the second thing you need to know is what type of crust is on top of each of the plates at the boundary. And remember, a boundary is just the place where two plates come together. One of the things that we talked about, one process that we talked about was something called subduction. And I think I've said to you that subduction is just where one plate actually dives underneath another plate. Okay, so this is a good image. This is a good picture of subduction. Subduction just means one plate diving underneath another. Well, we're going to talk about a second process today, right? Subduction is one process. So we said that subduction is a process that's going to destroy oceanic crust. So we're going to look at kind of its opposite today. We're going to look at something that creates oceanic crust. And the process that creates new oceanic crust is seafloor spreading. So seafloor spreading really just means that we can see this is a divergent boundary. At a divergent boundary, we have magma that's going to be rising up at this boundary because it's under less pressure, and it is going to erupt on the sea floor. Okay, it doesn't actually really bound out. Sometimes it just kind of seeps up and into cracks that we would find at this boundary. But essentially, this magma is going to come up and then it's going to harden. The lava itself, once it's above, is going to harden into rock. But I want you to think of like the center down through here as a big, long fissure eruption. So when we talked about volcanoes, we said a fissure eruption is just a long crack that lava pours out of along its entire length. And I think that's a pretty good way for you to think of this. So seafloor spreading is really just a way where new oceanic crust is created. And remember, it is the opposite of subduction. Keep in mind that this is going to be happening continually. Okay, so as you can see that this plate is moving this way and this plate is moving this way, albeit slowly. That means that there is always new crust that's being created. Okay, of course, this is only going to be at divergent boundaries, and you're always going to have two pieces of oceanic crust on either side. So let's look at a diagram with some more details. All right, so remember, we've got to know how the plates are moving. So this is a divergent boundary, and we have to know what kind of crust is riding on the side of each plate. So over here we have plate number one, okay, and over here we have plate number two. Here is this magma that's going to be rising up at this plate boundary, and it's going to be hardening into rock, and which is essentially going to be creating new crust. So this is the process of seafloor spreading. And one of the things I want us to look at is I want us to look and see what that means as far as landforms. So when we talked about mid-ocean ridges, we said that mid-ocean ridges are these really long volcanic mountain chains that are underwater, under the ocean. So I think this is a picture we looked at, and I want you to keep in mind that all of these are mid-ocean ridges. So these mid-ocean ridges are actually where we have those divergent boundaries and where we actually have seafloor spreading taking place. And you can see that these mid-ocean ridges are very, very, very long chains of volcanic mountains, okay, longest on Earth. So one of the landforms that's going to be created by seafloor spreading is going to be the mid-ocean ridge. And I want you to notice that when we look at this, it actually looks like two separate ridges, right? So we have a ridge here and we have a ridge here. And please notice that right in the middle, right at the plate boundary, we have what's called a rift valley, okay? Now, one of the interesting things about this particular type of plate boundary is that it's really tame. We don't really have any severe natural disasters here. There might be some minor earthquakes, but these are out in the middle of the ocean, and minor earthquakes out in the middle of the ocean, it's not exactly a natural disaster. so this is very much unlike subduction. Remember, at subduction, we had very explosive volcanoes. We had like these mega thrust earthquakes, and which created tsunamis. Um, Mid-ocean ridges and the seafloor spreading process is much tamer. When we look for examples, all we have to do is we just have to look, as far as the middle of the ocean anywhere. This is the Mid-Atlantic Ridge, but this is created. This is a landform that is created by seafloor spreading. Okay. Now, one of the things that this means, since we always have new oceanic crust being created, is when we look at the crust that is here closest to the plate boundary, that's always going to be our youngest crust, right? Because it's being made. And we're talking about a few million years. But when we move further away from this plate boundary, because remember, think of these plates are moving away from each other. The further we get away from the plate boundary in either direction, the crust gets older, right? This is crust that was created maybe millions of years ago. And when we get, even further away, when we get out maybe near a subduction zone where it's being destroyed, that's going to be our oldest crust. So, the sea floor is continually recycling itself. It is not the same age everywhere, which is a little strange to think about. So we're going to find the youngest oceanic crust is going to be right here, right next to our plate boundary. And as we move further away from the plate boundary, it's going to get older and older and older. All right, guys. I think we're going to stop there for today. We're going to look at one more divergent plate boundary tomorrow. I hope you guys have a great day.